Hello, and welcome to the webcast, to PostgreSQL and Beyond, Migrating Operational Challenges, sponsored by Stratoscale. I'm Tracy Cook with ADTMag.com, and I'd like to thank you all for joining us today. Before we begin, I'd like to cover a few housekeeping details. Please feel free to type your questions into the Ask a Question box on the console at any time during the presentation. We'll address as many of your questions as we can during the live event. And the entire webcast is being recorded and will be archived for future viewing. And we'll send you an email when that replay is available. And that should be in approximately 24 to 48 hours. And you can access the replay using the same link you used today. And now I'd like to introduce our speaker, John Mao, VP of Business Development at Stratoscale. John has more than 15 years of domain expertise in the IT and cloud space, including application development, marketing, and strategy. He's led the Stratoscale's business development efforts for more than 4 years. So it's with great pleasure I introduce John. And John, please take it away.
Great. Thanks, Tracy. And good morning, good afternoon, and good evening to everyone out there. Just kind of to set the expectation, and today we're going to talk about mitigating some of the operational challenges, specifically around enabling new database services like PostgreSQL within your organization. It's not a webinar that will give you all of the answers for your organization specifically, but hopefully this will give you at least a checklist and a framework of what to consider and plan before you engage in your Postgres database projects. So let's go ahead and get started. I think most of you are here because, as you know, Postgres, it's arguably one of the fastest growing open source databases in the world. If you go and look at some of the data from websites like DB Engines, for example, you can see the quite fast rise in both interest and adoption of Postgres, right up there, right below some of the commercial databases. Now, a lot of the reason, there's a lot of good reasons why this growth is occurring. Amongst the technical community, Postgres, it's really come to be known for two main important characteristics. Number one, it has been known to strive toward conformance to the SQL standard to a high degree. And number two, it's known to be a relatively stable and high-performing database as well. As a result of those two kind of technical characteristics, a lot of businesses are starting to look at their database strategy, and they're thinking, well, if this database is good enough, if it is good enough for my organization, it actually can help reduce cost dramatically as an alternative to some of the commercial databases out there. There's obviously also a really, really strong community that follows with the open source project, both from a technical perspective, but also from an industry perspective, from the support. Now, the tricky thing about most open source solutions, as some of you may know, there's always a but, right? And the but is that it's not really fair to do an apples to apples comparison between open source and commercial database systems, purely from a licensing cost point of view. It may seem like on paper that, okay, you're thinking, oh, well, Postgres is free, but that approach and that thinking, that mindset, it's actually quite misleading, because there are quite a few things that you must take into consideration before those economics start to make sense. So, don't get me wrong. I mean, there are a lot, again, of inherent benefits of open source. I mean, it's great to have open source technologies in the world today. Otherwise, we wouldn't be putting on this webinar. And obviously, with open source, again, you get a really great ecosystem, strong community, a lot of expertise globally, which ultimately is great from giving customers and businesses choice. And choice in not only technology, but also in people. But all of this goodness and all of this flexibility and this choice it also introduces a lot of complexity and sometimes some confusion around, what are some of those new risks and challenges that you may not be yet aware of with, like happens with most new technology. So in the rest of this webinar, we're going to effectively go through what we think some of the different types of risks and challenges that should, at least at a minimum, be on your radar if you're thinking about, or maybe you're in the midst of a database project. So don't be alarmed. There are definitely ways to help mitigate this risk, and we'll also discuss those solutions in some detail along the way. So when I look at Postgres, and not only Postgres, but actually all database projects, my background was actually in working from an engineering perspective on large database projects, and we oftentimes faced three phases of challenges and operational challenges and risks. The three phases that I typically think of, and I ask my team to think of, are really categorized in what you do from a pre-planning perspective before you launch, what you do once you've actually come time to actually push the go button and deploy for the first time, and then lastly, what do you do from an ongoing perspective to help support and maintain the database system. So some of the questions you want to be asking yourself are things like, what do we need from a planning perspective? What kind of migration efforts? And we'll walk through each of these three phases here in the next few minutes as well. So as far as planning before you launch, there are two kind of main categories of effort that you should take into consideration. One is around the deployment parameters, and the other is around what is your migration strategy for any existing databases you may have. So from a deployment perspective, there are multiple implementation approaches that really, at the end of the day, require an understanding of your business requirements. Performance may obviously be a factor, for example. Most people from a technical background would immediately jump to performance being a main focal point, but there are also other non-functional requirements to consider as well. So things like security risk, maybe even data privacy and regulatory considerations. And the good news is that regardless of your situation, Postgres is a database that it really can be deployed and instantiated almost anywhere. It can be run in a variety of environments, including not only on-premise in a private environment. It can be run on physical servers, on bare metal. It can be virtualized and run in a host. It could also be run in more of a private cloud environment. So if you have any sort of a private cloud environment that's kind of tied into a broader set of compute resources, you can do that. And then, of course, last but not least, you can also do this in the public cloud today, so the likes of Amazon, Google, Microsoft, and the likes. Now, if you have an existing database in either in a different system or platform, for example, a different database technology, or even if you're coming from an older version of Postgres, I think a critical part of your planning effort is actually to conduct a full assessment of what the migration effort is going to be. There's going to be functional tests you're going to have to run across workloads. There's going to be schema migrations potentially that you'll have to convert. There's going to be code migrations, and you have to be very careful with these last two because, in my own experience, version to version, even within the same database family, there could be oftentimes breaking schema changes from one version to another, and definitely between different kinds of relational database systems, there needs to be a lot of focus on, did you use any proprietary SQL commands in the apps tied to that system? So you want to flesh all of those things out so you understand what the scope of effort would be in order for you to make that migration if there is any work required instead. So this for most DBA, this is probably a very standard practice of the pre-planning kind of assessment of what you need to accomplish is pretty important. So we summarized here, again, from a deployment perspective, some of the things you want to be thinking about when you're talking about public cloud deployments versus private on-prem versus bare metal. There's a host of additional details you need to evaluate, from hardware selection, whether it's in the on-prem, or instance selection if you're running that in the public cloud, to the operating system. So if you're having to deploy this yourself, what operating system is going to be supported and required, and how are you going to support that operating system going forward, versus if it's running as a managed service, for example, in the public cloud, maybe that's a black box to you, and that's something that's going to be completely provided by the vendor. There's also a question around the packaging. So sometimes when you're deploying these database instances, depending on who's providing the database service itself, for example, in the public cloud, you may be unable to add additional packages required into your databases, or you may not be able to customize it to the same degree that you want in the public cloud versus doing something completely on-prem. Now, the flip side of the argument is when it comes down to automation and support and maintenance, is that on one end, as a managed service, all of that is taken care of for you. It's completely orchestrated for you. On the other end of the spectrum, when you're talking about doing this yourself in your own data center, suddenly, you may not have the same degree of automation available to you out of the box and being provided to you by someone else. So it's something that you're going to have to take on onto your shoulders instead. So it's something just to think about. Okay. So before we move on to the next section, just to take a quick poll of the audience to help us understand a little bit more about who's out there today. If you could just fill in a checkbox here. I think it's a pick one only checkbox. Where do you deploy, if you're deploying or considering deploy your Postgres database projects today? Number one, could it be, is it that's supposed to be on-prem, not on-perm, so apologize for that. Is it supposed to be public cloud into any of the individual public clouds like AWS or Google, et cetera? Is it multi-cloud? Is it going to be a combination of AWS and Google and so forth? Is it going to be some sort of hybrid cloud model where you're doing something on-prem for parts of your workload, parts of your applications, and then into the public cloud for others? Or is it something else entirely? So go ahead and make a choice, and we'll give you 10 more seconds, and we'll see the results, and we'll move on. All right, we'll move on. Okay, so it looks like the majority of you are still looking at, hopefully not on-perm, but on-prem deployments of Postgres. But there are some looking at more hybrid use cases as well. So I think hybrid is becoming a very, very popular choice where you get some of the elasticity for parts of your workloads, for example, for some of the compute instances, but perhaps your database is still something that you need to retain on-prem. So I'd be curious to learn more later from those of you, maybe in the Q&A section, of exactly what kind of scenarios you're envisioning. So thank you for your participation. Okay. All right, so we're moving on now. So now that you've made a decision as far as where you're going to deploy your databases, you have two additional big items to consider, kind of before you hit the go button, right? So security, number one, and then monitoring and logging is kind of a subset of that. These are both extremely critical to ensure success in your project as you go live. Security, as most of you know, in a Postgres environment and deployment, it actually needs to be a multifaceted strategy. So there's no single silver bullet that addresses security as a whole. You have to look at security from kind of three perspectives, in our opinion. Number one, around data encryption. So what is your data encryption strategy? Number two is around server configuration. So this is going to be around how do you limit access to the database in terms of maybe from a user permission roles perspective. And the last one is around general network configuration, so network strategy as well. And we'll dive into some of these in a little more detail in just a second. Monitoring and logging also, you need to create a plan for this because a very effective monitoring and logging strategy, if you don't want to be completely blind in troubleshooting when issues do arise or when people believe there is an issue, that's going to be very difficult to overcome. So having a plan for things like understanding key performance metrics, right, that you need to be monitoring. Also the frequency, right, the granularity. Sometimes different metrics require different levels of granularity that you need to monitor for each of these different databases. And then actually picking the tools, the right tools that can provide and track these metrics that you define as part of your plan. So when you talk about, so we'll dive in here a little bit more into each of those two areas. So, again, I think a holistic security strategy, it really takes, multiple facets into consideration. So again, on the server side, on the encryption side and network configuration side. So on the data encryption side, there's actually two very common security elements that you should be considering. Number one is around the data itself. So anything that's at rest, how do you, once it's actually put into the database, how do you actually secure that data? So with Postgres, you can use things like certain modules like a PG Crypto module, for example, that can be applied to both encrypt and decrypt data based on client keys, right? So clients provide the security keys that can unlock, encrypt, and decrypt these tokens. That's one aspect. The other aspect is around data encryption of data in flight. So when you're both inputting data, inserting data in the database, but also when you're querying data out of the database, how do you encrypt that in transit on the network itself? So Postgres obviously supports SSL out of the box, but it's something that you have to configure and set up to make sure that you take advantage of that. Now, the interesting, there's a little tip at the bottom here. The interesting thing is that with most cloud solutions out there, especially when you consider something like Amazon or AWS and their RDS specific service, and even private cloud vendors like Stratoscale ourselves, we've actually built a lot of these capabilities into the database platform itself. So just like in Amazon RDS, you can quickly go and easily enable encryption of all the data without having to manually manage all of the keys. And you can also do the same thing with enabling SSL, right? So being able to enable encryption of the network channel going to and from that database instance too. Right, server configuration is also equally important. So there's a very complex model, a granular model too, of how you define security within the database instance itself. So making sure that you ensure, the use and kind of employ the use of specific user role group models is very, very important. You need applications and anybody that's accessing these databases to fit into your permission models for how you provide that level of support. Postgres, like I said, has very, very granular support for these. You can define these different kinds of permission classes like roles, groups, and users, and also be able to tie that down into even specific, more granular things about the database, such as down at the table level, or sometimes even down even more granular into functions and even rows. The last one is around network configuration. So while not a direct part of the database itself, this is still very important. So this ranges from traditional network management practices around like ACLs, around IP address management for, defining who can actually access this, restricting the access to a certain number of inbound IP addresses. But that can be very difficult to maintain over time because as your requirements change, as user access change, as your applications change, that's a list that you'll have to maintain. But that's one very, very good preventative way. We also didn't mention here, but obviously limiting the types of ports that you can be accessing is also very, very important for database. You don't want, for example, to have a wide range of ports available. So all of these things from a network configuration must be considered. And again, I think one of the nice things of Amazon's database service is that because it's tied in with a lot of the rest of the infrastructure services, there is a lot of simplicity in terms of being able to enable an end-to-end security strategy from data encryption to server configuration to network configuration. And hopefully later I'll share a little bit about what Stratoscale is doing from that front as well. Okay. All right. So the other topic from a day one challenge perspective is really focused around monitoring. So I'm not going to read through every single one of these, but like I mentioned earlier, monitoring strategy is not only a nice to have, it's absolutely critical if you want to go into production, right? Like I said earlier, there's really nothing worse than being blind when an issue arises. So if you happen to be a DBA on this call, you understand the importance of a holistic monitoring strategy, right? And I think the most important thing that even as a DBA we have to understand is that the monitoring strategy, it really needs to not only cover some of the database attributes, right, some of the database metrics, but also you need to be able to correlate that with some of the infrastructure metrics as well. So is there a correlation between, for example, database query performance and CPU utilization or storage I/O performance, et cetera, right? So being able to see that kind of holistically is pretty nice to have, and something that you should try to accomplish. The other thing that is not articulated on the slide, I think is very important to consider, is that once you have a mechanism in place to instrument all of this data and all of this monitoring information, what do you do with that information? That's equally as important, right? Do you want notifications? Perhaps it needs to trigger some sort of remediation workflow if there's a well-known playbook for how to solve it. How about initiating other kinds of automation? Maybe you have a strategy of actually doing of increasing scale, for example, when one of these thresholds are reached, right? So, again, lots to discuss. I think monitoring in itself, it could be like a multi-hour discussion. But the bottom line and takeaway here is that, a comprehensive monitoring strategy, again, it's not optional. It's something that's mandatory before you actually go live, and you need to have that as part of your strategy when you hit that go live button for day one. Okay, luckily there are a lot of choices out there in the vendor community, and Postgres, because of its wide popularity, it also is it's natively supported by a relatively large number of vendors out there. There's a couple of examples up here. So from on-prem solutions like Nagios to SaaS-based solutions that can monitor your on-prem and kind of cloud workloads like Datadog, to built-in cloud solutions like Amazon with CloudWatch, or to private cloud solutions like Stratoscale. There's a whole bunch more, but there's a lot of these solutions that provide monitoring capabilities for your database, regardless of where you're running your database. So having a strategy that can hopefully meet your either on-prem or hybrid or cloud use cases, there's lots to choose out there. I won't pick one for you, but there's a lot that you could explore out there today. Okay, so we'll move on to the next poll question. If you don't mind, again, this is actually a multi-select poll question. If you could pick up to 3 the top challenges or maybe concerns or risks you had if you haven't started yet, as it relates to kicking off your Postgres projects, or maybe managing your Postgres solutions or deployments today. So is it potentially from migrating from other databases? Is it around the time for deployment? So maybe you have an environment that requires multiple instantiations, multiple deployments of new database instances. Do you have challenges around scaling? So how do you build a scaling strategy to support performance requirements? Is it around building a hybrid approach, right? So how do you manage for example, maybe it's around backups to the cloud, or a DR scenario to the cloud to form your hybrid strategy. Maybe it's around security. Maybe it's around building degrees of automation. Maybe it's around just general support. Upgrades, which is obviously always a challenge. Monitoring, like we just talked about, and even availability or reliability. So high availability, DR strategies, backup strategies, failover strategies, et cetera. So take a minute. I'll give you 10 more seconds to take your choices, because there's a few to read through. And again, if you could pick 3, we'll see what the audience is wrestling with today. All right, and we're going to move on now. Okay. All right, so it looks like, wow, a lot of input. Thanks for the feedback. So I see a lot of challenges. I think the top 2, as we can see here, are really around migration. So having a strategy for how to migrate from other databases. Deployment seems to be an issue. Support seems to be a challenge. And then hybrid. Well, surprisingly, hybrid is also up there from an implementation perspective, is also something that's challenging. Okay, so thanks again for your participation. We're going to move on and continue with the webinar here. Okay, and we're down to the last phase now. The last phase is, what we call, again, day 2 challenges. So now that you have something up and running, there are other things that you need to start considering. And some of these are actually challenges that you need to anticipate and also plan before day two. But I call these day two because these scenarios, they don't typically arise until after the initial deployment, right? So you have to have a strategy and a plan in place to answer these questions, but you may not actually have to pull the trigger on them and actually have to roll them out or enact them until typically after day one and sometime into day two and beyond. So these two areas are really focused around backup and availability, right? So these are questions around kind of the ongoing maintenance, around upgrades, and even the consumption model as well. So backup and availability around what do you do in a failure scenario? What do you do with handling data integrity? How do you handle failovers? What is the policy around that? And then from the upgrades and DevOps side, I think not only is it important to understand the performance of the application, but how do you provide ongoing maintenance and support for that? So maybe it's an upgrade required for security reasons or for functionality reasons. There lots of different reasons, but how do you ensure and define a process, and ideally an error-prone process to limit the downtime necessary for that? DevOps is on there because I think there's an emerging trend that we'll touch on later that also talks about that really forces the conversation around how do we help support the business in instantiating and deploying applications, which oftentimes requires a database in a much more quick and rapid fashion as well. So we'll touch on that in a little bit, but that's a whole other topic in itself as well. So we'll double click on the backup and availability one. So there's obviously a very, very wide range of options. Again, Postgres being a very popular database, there are a lot of choices today for both backup and DR in the wild today. And quite frankly, they range from very, very crude and primitive solutions to very, very extremely advanced and oftentimes associated with that very expensive solutions as well. So I think the first question you have to ask is really depending, what is your own internal SLAs that will drive this conversation, right? There are a host of options that, depending on your SLAs and what your commitments are to the rest of the business and the business criticality of your application, there are options that could be, either fully commercial, off the shelf, right? There are also other solutions that are more of a DIY or do-it-yourself solution. So let's talk about backup and disaster recovery strategies first. So with bare metal or VMs only, if you're looking for a very simple solution from a backup perspective, there are even open source tools available as part of the Postgres family that allow you to do very, very simple and crude periodic backups. So you can use tools like pgdump to do periodic backups into files and then be able to take that file and replicate that wherever you need using any other mechanism. Now, again, that's not something that's done as part of Postgres natively. It's something that you can use as a tool external to that, but that's a very, very simple way that you can use to do that. Now, in typical cloud environments, like in the public cloud, and even for private cloud solutions, there typically is a way to make this more policy driven. So because you're now provisioning Postgres instances, for example, maybe perhaps on a more frequent basis, you want to be able to define a policy that does a kind of a catch-all for different classes and different different databases for different environments, like through dev, test, and into production. And the nice thing about some of the cloud platforms is that they provide the ability to define these schedules and these policies for dictating how you do the backup, for dictating the frequency of the backups, for sometimes even to where do you do the backup to. So those are things that you should look for. I think if you're looking for a production solution, then obviously something that can do that, whether it's on-prem or even cloud-like in that nature, would be very, very important. And the other kind of capability that you really need to look for from a backup and a recoverability perspective is around point-in-time recovery. So this is a very, very important capability. Postgres luckily supports this. It actually supports this via transaction logs. So it does a continuous archiving, if you will, of every single transaction that's enacted against the database. And if you enable this capability, it allows an administrator to effectively go back to any point in time, any arbitrary point in time, and do a recovery up until that point. And that's very, very useful because you're no longer doing a backup via infrastructure capabilities. For example, you're not doing a VM backup or a storage backup. You're actually doing a database at a transactional level backup, which can be oftentimes a lot more complete and a lot more native to the database itself. So that's something that can be also done both in the public cloud. They have these capabilities, as well as some on-premise and private cloud solutions as well. The other aspect of backups and for availability is something called read replicas. So if you're not familiar with read replicas, it actually builds on the basic primitive capability of point-in-time recovery, which is transaction logs, and you have the ability to now use that to create effectively highly available configuration. So you can use that either for uptime scenarios, right? So if you need better availability, you can have a streaming replication of database transactions to another location, or you can also do this for performance reasons. So in other words, create read replicas across a multiple number of instances, and you can stick a load balancer in front as an example, and now you can actually spread your read logic and your read queries across the different replicas to improve the throughput of your application itself. So that's a very common way of using read replicas, both for uptime and availability. Okay. Again, that's used by the same mechanism. So oftentimes, when you talk about doing point-in-time recovery, if they have that capability enabled in the platform that you're running on, then suddenly you can actually kind of extend that capability to reach these two additional use cases around high availability and also for increasing scalable performance as well. Okay. Okay. Lastly is around upgrades. So upgrades are an unfortunate reality in the IT world, in the engineering world. It's something that we have to wrestle with. So upgrades are always a challenge, especially for databases, because databases are typically the thing that needs to be handled with care the most, because it's really the heart of the applications, it's where all the information resides that makes an application valuable. So this is a very, very big operational challenge, is figuring out how you implement and manage upgrades. So like I said, it's really inevitable, right? Your databases, they do need to be upgraded. They need to be patched for security vulnerabilities. They maybe even need to add new features that your application needs to take advantage of. And you have to decide how you want to do that. There's really two main strategies you can employ to make this happen. The first option is you do effectively kind of a replication in place, and then you do a failover. So what you do is effectively you create a new separate instance side by side with the older version that's already running today, and you do that replication side by side. You create another instance, and you migrate that data using a lot of, actually multiple techniques you could use. You could use either infrastructure-based replication, you can use database transaction log replication, and once that database is effectively synced and caught up to the same state as the original database, you can conduct a switchover immediately. Typically, you have to do this in terms of managing network addresses and IP addresses, but there's lots of techniques out there. I won't go into all the details, but lots of techniques out there to make that possible with very, very little if zero downtime at all. The other option is a little bit more invasive, but if you don't have the luxury of being able to kind of do the side-by-side flip over from an upgrade perspective, is you can actually do an in-place upgrade. So an in-place upgrade, as you understand, is actually upgrading the database engine itself. This is typically you don't have a choice, but you'll actually end up requiring some amount of downtime. So you'll have to take the database offline for some period of time while you perform the upgrade, and hopefully whatever mechanism you use is fully automated. So when you do that, it will go smoothly. It'll be repeatable, something you've tested in dev and test environments, so that you can minimize the downtime, that window, that maintenance window that's required to only take this application offline to perform the upgrade itself. Okay. All right, and then I just touched on this, and I'm just going to close out on this one slide. So, if you're in an organization, there were some folks that talked about challenge about rapid deployment. So I'll speak to that segment of the cross-section of the audience right now. So what we're finding at Stratoscale, we've talked to a lot of companies that are trying to become more agile as not only a database team, but as an IT organization as a whole. And one of the reasons why they're looking to become more responsive and agile is to support some of the ongoing CI/CD initiatives. So, the DevOps initiatives, for example. So the rest of the business, typically they're looking to move faster in terms of building apps faster, testing apps faster, launching and deploying apps faster. And so part of what you should be considering as well is, if that is a requirement for you, how do you help contribute in kind of shortening the deployment time, or completely eliminating it to make it fully automated, right, in order to support the rest of the business as they're transforming into more of an agile methodology, across the lines of business itself. So it's not mandatory, but definitely, there is one line of thinking, which is, how do you build a more agile approach to not only delivering a database, but how do you deliver a database service to those customers internally as well? Okay. Last question, how many Postgres instances are you running today or expected to run in the next 12 months? Be curious just to see the scale. Some of you, I'd be curious if you're running one big Postgres database, or maybe some of you are more in the kind of CI/CD mindset, where you're giving your application development teams access to more and more smaller instances of databases, for example, and what does that look like in your organization? I'd be very curious to see the results. So we'll give you guys, this is just a one choice option. We'll give everyone 10 more seconds, and we'll move on and wrap this up and hopefully go to some Q&A. Okay. All right, so we see less than 10 predominantly, so most people are still probably figuring out how to, I'm assuming this is very much aligned with the migration poll we did earlier, so more about moving from existing databases potentially into Postgres, so that's great. So less than 10, hopefully this has been helpful in kind of helping you if you're just starting that journey and understanding what that, what kind of key considerations you should be thinking of when you're launching your new database projects. Okay, so just a quick summary. Okay, so this was a very, very high-level view of all of the different aspects that you should be considering. Hopefully there's something at least new that you picked up in here. Again, I think the interesting thing is that in 2019 today, the choices of where we want to deploy databases, it's more than ever before. We have the luxury now of deploying not only in our own private data centers, our own environments in the past, but also the ability to deploy into more modern private clouds, or even into the public cloud as well, okay? And through each of these different locations or environments in which you're trying to deploy, just keep in mind that you see all of the rows and all the labels on the left, from deployment to migration to security to monitoring to backups to availability to ongoing upgrades, even to supporting DevOps and CI/CD initiatives. There are different choices to be made depending on the environment. So depending on your own organization's requirements, some of these may have some explicit strengths. Some may have some more implicit weaknesses. But those are the trade-offs you have to work through. And depending on your own business requirements and your customers' requirements, there may be, hopefully this table will give you an idea of what might be the right choice for you and your application team and your organization as a whole. Okay, so just one slide. So talk about Stratoscale. So like Tracy mentioned, I'm actually heading up business development for a company called Stratoscale. We have built a platform that helps hopefully some of you with some of the challenges that we just outlined today. So we have an automated database platform that takes care of a few key things around Postgres inside of your own private environment. So for those of you that are looking for an on-premise solution behind your firewall, for example, a lot of the challenges that we outlined today are exactly the kinds of things we built into our platform. So we provide, for example, out of the box, we provide automation of a lot of the operational aspects that we discussed today in your own enterprise environment, right? Specifically around Postgres. We enable you to have a single-click deployment model. So with literally one click of a button, you can provision a database, an instance of Postgres in your own environment. But not only that, we actually can provide all of the ongoing upgrades, right? So patching, for example, we help automate that process in multiple ways. We also provide all of the automation around scaling. So we talked about replicas, for example, not only for backup scenarios, but also to provide better uptime, provide better availability, to provide better, even for better DR scenarios, and also for performance, right? So being able to scale out performance reads across a wide range of replica sets is also something that we do, and it's fully automated. You don't have to actually do that configuration yourself. We've also integrated in all of the monitoring of not only the database, but also the infrastructure itself. So you get to see nice correlation between the infrastructure metrics and also the database metrics that it's running on. That's hosting it, actually, I should say. That's all fully integrated out of the box. You don't have to do any extra work, and we provide that all through a single pane of glass. And then lastly, one thing that's pretty unique to us is that we provide a set of APIs that's modeled after the public cloud. So if you do have DevOps teams or CI/CD teams and workflows, or maybe you're pursuing what people are now coining as infrastructure as code workflows, IAC, we have a set of APIs that help make that completely super, super easy to do, and something that you can do and kind of plug into whatever workflows you may already have. This is also a way for those of you that are looking at hybrid cloud for streamlining the workflows across both the public cloud and your private infrastructure. So more information on our website about that. And the other thing is, although this webinar is talking about Postgres specifically, our database platform actually accomplishes and does and performs the same exact types of operations and automation across a wide range of database technologies, open source primarily, but even some commercial databases as well. So not only is it Postgres, but we also support MySQL, and we also support MariaDB. We even support cluster databases like MongoDB and Redis and so forth. So keep that in mind. We can help you with either a Postgres-specific project or actually a wide range of database projects across different database technologies as well. Okay, so that's the end of the webinar portion. We'll go into some of the Q&A section, and we'll pull that up if we can just get a section. And Tracy, I don't know if you guys have gotten some questions queued up.
Yeah, sure, we do. I wanted to remind the audience to please submit your questions, and we'll get to as many as we can this afternoon. And here we go. What are your considerations for on-prem containers, such as within OpenShift?
So what are your considerations for on-prem containers, such as within OpenShift? So I think the question, if I'm wrong, please clarify who asked the question, but there's one kind of train of thought, which is now we can run databases actually inside of containers themselves instead of inside of VMs. And that's true, and that's something that is obviously a deployment choice as well. I think that it doesn't really change the operational challenges that we outlined today. Regardless if you're deploying in a container or in a virtual machine or on bare metal, these same operational requirements are going to be necessary. So just because you deploy in a container, for example, doesn't mean you no longer need to worry about upgrades, right? It doesn't mean you no longer need to worry about availability. Now, the mechanism and how you actually implement it might be different, but that's not necessarily eliminated, I should say, by using something like a container. So I'm not sure if that answered the question or not. But if not, please, maybe we can clarify from whoever asked the question.
Great. All right, sure. Yeah, if you need more clarity, please send us back a message. We have another question here. What web interfaces are available with 4GL programming access to the databases, particularly for private or hybrid settings?
Oh man, I'm going to get stumped on this one. So that probably is a question that I need to pull in one of our database engineers to answer. I don't know that off the top of my head, so I apologize. But we will follow up with you. I think we have, Tracy, we have their information, right? So we can send a note back to give you the answers to that question.
Okay, sounds good. How about when migrating to Postgres, do you recommend one large database like Oracle or several small databases?
It's a great question. So I don't think there's, again, a single answer for this. I can tell you what we typically tend to see. I think in more of the cloud mindset today, most organizations are starting to treat databases as just another resource. In other words, in the old days, you would think about, I remember coming out of the university, my first database I worked on was DB2 running on a mainframe. And, that was one very, very big database used by lots of different people. In the cloud era, it's a little bit different mindset. It's typically databases are viewed as just another resource as part of a specific application. So we do tend to see more and more folks spinning up more and more smaller instances, relatively speaking, than kind of the big Oracle databases of the past or DB2 databases of the past. So, again, that obviously there's a huge caveat there, depending on what the application requirements are. That could, it varies. So I don't want to give a concrete kind of one answer or the other, but I think that's something to consider. That's something we do see a lot, which is, again, kind of in line with some of the rapid provisioning requirements needed by most of our customers today.
Okay, very good. Thank you. And if anybody has a question, please submit it. We'll be happy to answer it. And here's our next question, John. How can I how can I get the same support SLA as I get from Oracle?
Okay, so good question. So obviously support, like I mentioned earlier, the nice thing about something open source like Postgres is that there are a lot of vendors out there that will provide support for different technologies. So Stratoscale specifically, I think we provide a certain level of support definitely from the infrastructure level up to the database. But if you're looking for a deep level of database support, there's actually a bunch of companies out there that specialize in just providing, for example, Postgres support. If there's interest, if you just do a Google search, there's a lot of them. One of the most most popular ones would be companies like Enterprise DB. So I think what they provide, though, I think the distinction here we need to clarify that the support that they provide is actually in the Postgres database itself, whereas a lot of the challenges that we described today are kind of outside or kind of around the edges of Postgres, and that's something. So those are not. Those are not in conflict with one another. In other words, those are oftentimes complementary, and you need both, right? You need someone that can provide you support when you have a deep technical question inside of the engine itself of the database, but you should also be thinking about other kinds of vendors and technologies that can help provide operational support for maintaining and running the database in a production enterprise environment as well.
Very good. Here's another question. It's an interesting question. What's necessary for the code migration from Oracle to Postgres? The databases are not 100% identical.
Yeah, so that's a good question as well. Tough question. I think, again, I touched on this earlier, but I think from a code migration perspective, you have to look at it from two angles. You have to look at it from the database itself. So those are things like, schemas, stored procedures, views, triggers. I mean, whatever you're using inside of the Oracle database, you have to have a good understanding of what those things are, and you have to map them. Most of the time, there will be some work to translate that, and there are tools out there, by the way, not provided by Stratoscale, but other tools out there that allow you to do those kinds of conversions from one database technology to the other. But I think also it's important, that's on the database side, but it's also equally important to understand that a migration also requires an evaluation of the application or whoever's actually accessing that database. Because if, for example, there's an application server or a web server accessing an Oracle database, you have to ensure that there's no proprietary calls, for example, from Oracle in that code base. And if there is, then you have to time that cutover and that migration with the application team itself. So.
Okay, very good. That's the end of the questions. Is there anything else you'd like to cover before I close out the event?
Yeah, I think just lastly, there's if I didn't do a good job, and I just saw that there are some people complaining about audio problems, so I apologize. But if there is any questions, we're actually sending out, obviously, the recording, I believe, right, Tracy? But we're also sending out a much deeper, in-depth guide covering some of these topics in more depth. So I believe every attendee will be getting a copy of that PDF in their inbox over the next couple of days as well, if not a couple of hours. I don't know when it's going out. But I think that's it. And I just want to say thanks for everyone participating and joining and participating in the poll as well. It was great to kind of understand the landscape of Postgres, and hope to speak to everyone soon.
Oh, thank you so much, John, and thank you so much for joining us today. We really appreciate you taking time to present to our audience, and I'm sure they learned a lot. And I'd also like to thank the audience for attending today's webcast. The webcast was sponsored by Stratoscale and presented by adtmag.com. Thanks again, everybody, and enjoy the rest of your day.